Hello everyone, this is Lalita Devi, Senior Math Faculty, and I welcome you all once again back to the transition course conducted by Sri Chaitanya Academy. So coming to the today's session, we will discuss about the most important topic, that is nothing but operations on sets. So in our previous class, we have discussed basics about the sets, like what are the set and what are the types of set and how can we analyze the given two sets. Now in today's session, we are going to discuss about operations on sets. Okay. So let's see what are the four basic operations that we can conduct, or that we can perform on the sets. First one is the union and intersection and difference and the complement. So we will discuss about these four operations in detail in our today's session. So let's first discuss about the union. So union of two sets. So generally we can say that we are having the two sets A and B. So how can we do the operation union? Means union of two sets will give you the combined elements of A and B. It means, so for example, if we take an example of, I am having a set A which is of set of 1, 2 and 3. And consider we are having the set B which is the set of 3, 4 and 5. Okay. Now we need to perform union between the A and B. So union between A and B will be represented by U. This is the capital Greek letter U we are going to take in order to represent the union between the two sets. Now A union B will be given by the 1, 2, 3. So we can write the common elements for one time. So that becomes 1, 2, 3, 4 and 5. Okay. So now union between the two sets will give you the combined elements of both the sets. So as you can see that union of two sets A and B, so will give you the result set C, which consists of both the elements that we are having in both A and B, and we can use the symbol U, that means the capital U, you can use in order to represent the union between the two sets. Now let's see what are the basic properties we are having for the union of the two sets. So coming to the first property is the commutative law. As we know that commutative law means we are having A union B will be equals to the B union A. And next one is the associative law, where we will get A union B whole union C will be given by A union of B union C. And coming to the next is the law of identity. So we know that we are having the identity in the sense that will reflect the same. So now if you take an addition identity, it will be of 0, because if you add anything to the 0, you will get the same value. And multiplicative identity will be 1. It means if you multiply anything with the 1, you will get the same thing. In the same way, so what will be the identity? Identity law means here 5 will act as a identity 1, which will give you on union of any set, you will get that set value. Okay. Now moving to the next one is the idempotent law. It means if you are doing the union between the set itself, then you will get the resultant as the set. Now moving to the next law of universal set. As we know that capital U will represent the universal set. So if you take the union of an universal set and A will be the subset of U. So here A will be the subset of U. Okay. So now if you take the union of the universal set and the subset, then you will get the resultant as the universal set. So coming to here, we can simply remember that union means nothing but we are going to combine the elements of both the sets and we are going to write it in the form of a union set. And most importantly, we need to remember what are the properties we are having for the union of sets. Okay. Now let's solve a simple problem on the union of set. So now find the union of each of the following pairs of sets. Now here they gave first one, x is of 1, 2, 3 set of, and y is of 1, 2, x is of 1, 3, 5 and y is of 1, 2, 3. So as we know that union means we are just going to combine the elements of both x and y. So here it will become x union y will be given by set of 1, 2, 3 and 5. So here I am just writing my repeated elements for only one time. So now moving to the next, A union B. So A union B will be given by, so I am having A, so it was of A, B, C, E, I, O, U. Okay. Now moving to the next. A is the set of 1, 2, 3 and B is the 5. 5 means nothing but a null set. So now we are having the identity law, law of identity, that if you are doing union of any set with the 5, then you will get the same set, right? Now here if I am taking my B, so here A union B will be given by A union of, where B is the 5, so A union of 5, so which will be given A. So it will become the set of 1, 2, 3. Okay. Now moving to the next. We are having A is the set of X, where X is a natural number and multiple of 3. So we can take the multiple of the 3. So you can remember that in our previous class we discussed about representation of set. So now if you observe here clearly, in the 3 questions we are having the sets in the form of the roster form. But coming to the 4th question, for the sets they gave the set builder form. So now we can convert that set builder form into the roster form, where we will get A is the set of X is a natural number and multiple of 3. So our X values can be 1, 2, 3 and so on. But those values should be multiple of 3. Multiple of 3 will become 3, 6, 9, 12, 15 and so on. Okay. Now coming to the B. B is the X, where X is the natural number but less than 6. So less than 6 means what we will get? B is the set of 1, 2, 3, 4 and 5. Okay. Now they are asking us to do the operation union between the A and B. So we are going to get A union B will be equals to the set of, so we are just going to write the common elements for one time. So that becomes your 1, 2, 3, 4, 5 and 6 and so on. Okay. Now moving to the next. A is the set of X, where X is a natural number and it lies between the 1 and 6. And it is equal to 6 also. So that becomes A equals to set of. So we are not going to consider 1 because it should be less, it should be between the 1 and equal to 6. So it is of 2, 3, 4, 5 and 6. Okay. Now moving to the next. B is the set of a natural number but it should lie between the 6 and 10. So our B will become set of 7, 8 and 9. So here we are not considering 10 also because we are having X between only 6 and 10. So we are just going to take 7, 8 and 9. So here A union B will be equals to set of 2, 3, 4, 5, 6, 7, 8 and 9. Okay. So this is how we are going to find the union of sets. So all these are like your basic concepts only, but when it comes to your relations, that time it will be little bit difficult. So now practice a lot on these basic concepts, and whatever the doubts you are having, just clear them there itself. So now moving to the next, we will discuss about the intersection. Intersection of sets means we are just going to take the common elements between both the sets A and B. So if we are having a set A, which is of alphabets, so if you take A, B, C, D, E, F and so on, okay. If you take an example of set A, which is the collection of set of alphabets, and if you consider B is the set of vowels, so that is nothing but A, E, I, O, U, okay. Now here intersection means we are just going to take what are the common elements we are having in both the sets. So now A intersection, so downward U we can use as the intersection. So now A intersection B can be given by A, E, I, O, U. So why? Because whatever the vowels we are having, those vowels will be there in the alphabets. So A intersection B will give you the set of vowels. Okay. Now let's see the properties of the intersection. So how can we define the property for the intersection of set means, if we consider an element X, so that element X should belong to both the sets A and B. Okay. Now moving to the next. So same properties we are having for the intersection also, that is commutative law, which is A intersection B will be equals to B intersection A, and next it is the associative law. A intersection B whole intersection C is equals to A intersection of B intersection C. Okay, and next is the law of phi and the U. So that becomes your phi intersection A is equals to phi. It means if I am having a null set, okay, phi will usually represent a null set. Okay, and just consider A, we are having the set of 1, 2, 3, a simple example. Now, in our last class, we have discussed that phi is the subset of every set, right? So now, we will be having the element phi in the set of A. It means our phi and A are having the common element which is nothing but our phi. So that's the reason we will get phi intersection A equals to phi. Okay, and U intersection A, it means universal set intersection A. If you take an example of Venn diagram, so this is the universal set and just consider that it is the A. Okay, so now I am taking the intersection between these two. It means we are having A which is the common between U and A. So that's the reason we will get U intersection A will be equals to A. Now moving to the next is the idempotent law, where we will get A intersection A will be equals to A. Next we are having the distributive law. So A intersection of B union C will be equals to A intersection B union of A intersection C. So here we can say that our intersection is distributed over the union. Why? Because here I am taking the union, I am taking the intersection and I am just distributing over the elements or the sets that are in the union. Okay, so here whatever the intersection we are having, we are distributing that, it intersection with the union sets. Okay, now moving to the next is the disjoint sets. Disjoint sets is nothing but just an extension of the intersection. So if we are not having any common elements between the two sets, like just consider an example of A, which is the set of 2, 3, 4 and 5, and another B, which is the set of 6, 7, 8 and 9. Okay, now if you observe here clearly, we are not having the common elements between the A and B. So if you take A intersection B, you will get phi. It means we are not having any elements in common between them. So we will get the intersection value as the phi, which is nothing but your null set. So what we are going to call this both A and B. So both A and B will become the disjoint sets. Okay. The name itself will tell you that if you are not having any common elements between both the sets, then we are going to call them as the disjoint sets. Okay, so now let's solve a simple question on the disjoint sets. Which of the following pairs of sets are disjoint? So now if you take an example here, we are having the set of 1, 2, 3, 4. So I am taking it as A, which is the set of 1, 2, 3 and 4. Okay, now take it as the B. B is the set of X, where X is a natural number and it lies between the 4 and 6 and equals to 4 and equals to 6. Now B will become set of 4, 5 and 6. Okay, now they are asking us to find A intersection B. So what is the A intersection B will become here? So we are just going to write the common elements between them. So if you observe here clearly, we are having only one element which is nothing but the 4 between them. So our A intersection B will become set of 4. Okay, and if you observe here clearly, we are having only one element in this set. So it becomes a singleton set, what we discussed in our previous class. Okay, now moving to the next, it is the set of AEIOU and it is the set of CDEF. If you observe here clearly, here also we are having a one common element which is the E. Okay, so now that becomes your, if you take the intersection, that becomes your E. Okay, so A intersection B will give you the set of E. Okay, but if you observe here clear, they are asking which of these sets are disjoint. But coming to the first one, we are having at least one single element. So this will be not disjoint. right? And coming to the second one also, if you take the intersection between these two sets, we are getting one of the common element, that is the E. So therefore it is also not disjoint set, right? Now moving to the next, x is an even integer and x is an odd integer. So we know that even numbers and odd numbers are different, because even numbers are the multiples of the 2, right? So now here these two are also, these two are not having any common element between them. So if you take an example, even integers, in the sense we can start taking from -2, -4 and so on, okay? And here it will be 0, and here it will be 2, 4 and so on, okay? And coming to the odd integers, it will be of B is the set of -1, -3 and -5 and so on. And coming to here, it will be of 1, 3, 5, 7 and so on, right? So now if you look at an example, we will be having, we will be not having any common element between them. So if you take the intersection between them, so A intersection B will give you the null set. So we are not having any element in that. So now these two will form a disjoint sets. Now moving to the next, we will solve one question on the intersection. So now if A is the set of 3, 5, 7, 9 and 11, and B is the set of 7, 9, 11 and 13, and C is the set of 11, 13, 15, and D is the set of 15 and 17. Now find A intersection B. So in order to find A intersection B, first of all we are going to take what are the sets we are having. So it means we are having A is the set of 3, 5, 7, 9 and 11, and B is the set of 7, 9, 11 and 13, okay? So if you are getting confused how to find the intersection, means simply write one set below another set, okay? Don't write like in your horizontal way, okay? You can write in the vertical position of the sets. From there you can clearly find what are the common elements you are having between those sets. So now A intersection B, so here clearly we can find 7 is the common element, so 7, and 9 is the common element, and 11 is the common element. So our A intersection B will become 7, 9 and 11. And moving to the next, B intersection C. So we are having B is the set of 7, 9, 11 and 13. And C is the set of 11, 13 and 15, okay? Now if we take B intersection C, so here clearly 11 and 13 are the common elements. So we can write 11 and 13, okay? Now similarly we can write for A intersection of C intersection D. So most of the students will get a doubt that how can we solve if we are having the 3 sets in the intersection. So now if you take A intersection whole intersection of C intersection D, okay, understood? Now these can be equals to your A intersection C whole intersection of D. As we learned in the associative law, we can apply this and we can solve it. So now we will take A, which is the set of 1, 3. So we are not having 1, so 3, 5, 7, 9 and 11, and B is the set of 7, 9, 11 and 13, and C is the set of 11, 13 and 15, and we need the D also, so let's take D also. So D will become 15 and 17. So if I am taking my LHS, it will be of A intersection of C intersection D. So first of all we need to find C intersection D. So C intersection D will give you, so what is the common element we are having? Only one element, that is the 15, okay? Then after we can take A intersection of C intersection D. So now if you take C intersection D, we are having only one element, which is the 15, and A we are having set of 3, 5, 7, 9, 11. And if you look at these two sets, we are not having any common element. So we can simply write 5. Okay. Now the A and the C intersection D will become your disjoint sets. Now let's see A intersection C. So A will be the set of 3, 5, 7, 9 and 11. And C will be the set of 11, 13 and 15. So now if we take A intersection C, we are going to take the common element, so which is nothing but our 11. Okay. So this is how we are going to solve the intersection problems. So all these will be the simple problems and we can find it very easy to do. And they are like very funny also. So you can try the next problems on your own. So pause your screen and take the question and do it as your homework question. Now moving to the next, we will discuss about the difference between the two sets. So how can we find the difference between the two sets? As we know that difference means we are going to do the subtraction, but how can we do the subtraction of the two sets? Like see, if we are having the two sets A and B, so just consider that we are having some of the elements, whatever the portion here we are having, it represents A intersection B. Okay. Now, if I am taking my A minus B, I am just going to write whatever the elements that are completely belongs to the set A, and we are just ignoring the common elements between the set A and B. So now, whatever the portion that we are having in the blue color, that will represent the A minus B. Okay. And here we can do B minus A also. So if we are doing B minus A means the elements that are completely belongs to the set B. Okay. And we are just not taking the common elements between the A and B. So here this complete portion will become B minus A. Okay. So here there is a difference between the A minus B and B minus A. So please be careful when, regarding whatever they are asking. So check whether they are asking A minus B or B minus A. Okay. Now the difference of the set A and B will give you the elements that will belong to the only set A but not to the B. Okay. And we can write them as A minus B, and you can read it as the simple A minus B only. And how can we say that with the help of set builder form means whatever the elements we are having that belongs to the only set A but they doesn't belongs to the set B. Okay. Now coming to here, from here we can say one thing. See, our A minus B values are different and A intersection B values are different and B minus A values are different. So now what we can say clearly from this means the three sets which are of A minus B and A intersection B and B minus A, these three sets are the disjoint sets. Now if you take an example of any of the two sets and if you find these three like A minus B, A intersection B and B minus A, you can find these three are the disjoint sets. It means they are not having any common elements between them. Okay. So now let's see the extension of difference of two sets. That is nothing but the symmetric difference. So what is the symmetric difference means? If we contain, if we are having a set A and set B. Okay. Now if you are taking the two, A minus B and B minus A both. Okay. And if you are taking the union of them, then you will get the symmetric difference which is represented by A delta B. Okay. It means if you are taking the union of both the differences A minus B and B minus A. Okay. So I am taking A minus B and B minus A union. Then we will get the symmetric difference and which will be represented by A delta B. Now we can write it in the another form also. That is, if you look at here, these two circles will represent the sets individually. But if you take the complete two, like if you just take the combination of these two sets, we will get what? We will get A union B. Okay. If you are combining both the sets, you will get A union B. So now from this, what I need to subtract in order to get my symmetric difference? So these are my symmetric difference part, right? And this is my union. So from this complete union, if I am subtracting this intersection part, then I will get the symmetric difference. So it will become A union B minus of A intersection B. Okay, so from the combination of the two sets, if you subtract the intersection, then you will get the symmetric difference. So our A delta B will be given by A union B minus of A intersection B. Okay, now let's solve a problem on difference of sets. If A is the set of 3, 6, 9, 12, 15 and 18 and 21 and B is the set of 4, 8, 12, 16 and 20, and similarly we are having the set C and D. Now they are asking about find A minus B. So first of all we are going to take the sets where A is given by set of 3, 6, 9, 12, 15 and 18 and 21, and B is the set of 4, 8, 12, 16 and 20. Okay, now they are asking us to find A minus B. So A minus B means what we have to write? We have to write the elements of the A which are not common between the A and B. So if you observe here clearly, 12 is the common, okay, and we are not having any other common elements. So our A minus B value will become 3, 6, 9, 15, 18 and 21. Okay, now let's see. For suppose we will check B minus A value. B minus A value in the sense we have to write the elements that completely belong to B by not considering the common elements between the A and B. So 12 is the common element. So we are just removing the 12 from the set B. So that becomes your 4, 8, 16 and 20. So these will be the B minus A set. So if you observe here clearly, we are having different elements for our A minus B and B minus A. So that's the reason the order of taking difference of two sets also plays the major role whenever we are solving problem. Why? Because our A minus B and B minus A are completely different, and we need to go for the, we need to check in which order we are taking the sets. Now let's go for the A minus C. So as we know that A is the set of multiples of the 3 up to the 7, and C they gave it as set of 2, 4, 6, 8, 10, 12, 14 and 16. Okay. Now if you look at here, between A and C, what are the common elements we are having? We are having 6. Okay. And next we are having 12. Right. So now we have to write whatever the elements that we are having in A by ignoring the common elements. So that becomes your set of 3, 9, 15, 18 and 21. See, in our set C, we are not having 18. So we can consider that in our A minus C. Now moving to the next, A minus D. A is the set of multiples of 3 that we know. Now D is the set of 5, 10, 15 and 20. Okay. So now if you observe here clearly, we are having only one common element, that is the 15. So by removing 15, the remaining elements all will comes under the A minus D. So our A minus D will be equals to set of 3, 6, 9, 12, 18 and 21. Okay. Now as already we did, the B minus A value will become 4, 8, 16 and 20. Now let's move to the next. So as we know how to do the difference between the sets, now let's take this question as the homework, and I hope you will do it. And you will, if you are having any doubts, you can ask them in our next session. Now let's see the complement of your set. So complement of your set is nothing but, just assume that you are having a universal set, and from that universal set, one of the set is your subset A. Okay. So my universal set is the U, and in that universal set, I am having one of the set that I am considering as the A. And I am saying that this A is the subset of the universal set. So now whatever the elements that we are not having in the A, okay, and that belongs to the universal set, that becomes your A complement. Okay. Now complement of your set means we are going to consider the elements that are not in that set, but that belongs to the universal set. Okay. Now we can write it as where A is the X, set of X, where X belongs to U, but that does not belongs to the complement, for which set you are taking complement, that elements, complement set will be not having the elements that belongs to the set. Okay. Now let's see the properties of the complement of the set. If we are having A is the subset of the universal set U, then the complement is also a subset. Why? Because see, from the diagram only we can answer that. I am saying that A is the subset of the universal set, and now whatever the elements that are not belongs to the A but that belongs to the U will become the complement. So now whatever the elements you are having the complement also, that becomes the subset of the universal set. Now moving to the next is your complement class, that is A union of A complement will give you the universal set. Union means what? We will write combinedly. So if I am combining my set with the universal set, what I will get? I will get the universal set only. Now let's take an let's take the next one. That is nothing but A intersection of A complement equals to 5. So I am saying that A is having some set of values and A complement is having some set of values, but those values are not in the set of A. It means these two, like you can take an example. A is the set of 1, 2, 3, 4 and 5. Okay. And our universal set is the set of 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. Now what is our A complement will become? A complement will become, so you just remove whatever the elements of A from the universal set, then whatever the set you are having, that becomes the complement. So now here it will become, if I remove the A from the universal set, it will be of 6, 7, 8, 9 and 10. Okay. Now if you observe here clearly, A and A complement are not having any common elements. So if you take the intersection, then it becomes the 5. So now moving to the next is the De Morgan's law. So this is the most important law. So listen carefully. If we are having A union B whole complement, then see here, union will become the intersection. Okay. Here I am taking the whole complement, and when you divide that whole complement, the union will become your intersection and it becomes A complement intersection of B complement. And in the same way, if you take the complement for the intersection, intersection will become the union. Okay. So it means A intersection B whole complement will become A intersection union B intersection. Okay. So De Morgan's law, you can clearly remember that if you are taking the complement of an intersection, you will get the union individually. Okay. It means if you are taking the complement of intersection of two sets, that becomes you are going to take the union of complement of the sets individually. Okay. Now moving to the next law of double complementation. It means, as we know that A complement whole complement will be equals to A. And next law of empty set and universal set. So here if you take the complement of the phi, it means if you take the complement of the null set, that becomes the universal set, and if you take the complement of the universal set, that becomes your null set. Okay. Now let's solve another question. So now this is the question that we are going to solve on the complement. So let U equals to set of 1 to 9, and A is the set of 1, 2, 3, 4, and B is the set of 2, 4, 6, 8, and C is the set of 3, 4, 5, 6. Now let's find the A complement. A complement means we are having the set, universal set. Okay. So let's take the U, which is the set of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And now they are asking the A complement. So from the universal set, which set we have to remove in order to get the A complement? We need the A complement. So we are going to remove the set of A from the universal set. So now the set A is given by 1, 2, 3 and 4. Okay. If we remove the elements of the set A from the universal set, then we will get the complement of the set. So that becomes your So I am removing 1, 2, 3, 4. So A complement will become 5, 6, 7, 8 and 9. Okay. Now let's see the B complement. B complement means, so we are going to remove the elements of the B from the universal set. So B is the set of 2, 4, 6 and 8. So from the universal set, just remove these 4 elements. So we will get B complement equals to set of 1, 3, 5, 7, 8 we have to remove, so it will become 9. Okay. So still any left? No, right? So now next it is of A union C whole complement. So how can we do the A union C whole complement? We can use the De Morgan's law, right? A union C whole complement. So it means what it will become? Union will become intersection. So A complement intersection of C complement. Okay. Now we know the A complement. So just find the C complement. C equals to set of 3, 4, 5 and 6. Okay. Now what is the C complement will be? So from the universal set, just remove these elements. So we will get 1, 2, 7, 8 and 9. Okay. Now we need to take the intersection between the A complement and the C complement. So if you observe these two sets clearly, we are having the common elements of 7, 8, 9. So now A union C whole complement will be equals to set of 7, 8 and 9. Okay. This is how we are going to find. So same we can use for the fourth one also. That is of A union B whole complement will be equals to A complement intersection of B complement. So we already know what is the A complement is, which is the set of 5, 6, 7, 8 and 9. Okay. And we know B complement also, which is the set of 1, 3, 5, 7 and 9. Right. Now we have to take the intersection between them. So let's see what are the common elements. So 5 and next it is the 7 and next 9. So we will get A union B whole complement will be equals to A complement intersection of B complement, which is equals to set of 5, 7 and 9. Okay. So this is how we are going to find the complement of the given sets. Now moving to the next. So let's solve a question overall if by taking whatever the operations we can do on the sets. Okay. Now if X is the set of A, B, C, D, E, F, G and universal is the, so they gave the universal set which is from A to G and X is from A to D and Y is from F to G. Then find X minus Y and Y minus X and X intersection Y, X union Y and X complement. So now let's solve the X minus Y. So for that let's take X, which is the set of A, B, C, D. Okay. And Y, we are having the set of F, B, D and G. Okay. So X minus Y means what we will get? We will get the complete elements. We will get the elements that are completely belongs to the X. So avoiding the common elements between the X and Y. So if you observe here clearly, we are having B and D are the common elements. So just remove B and D from the X and write the same. So that becomes your A comma C. Okay. Now let's go for the Y minus X. The same. So we are just removing whatever the common elements, but here it is Y minus X. First letter is Y. So we are going to write the set Y by just removing whatever the common elements. So that becomes your set of F comma G. Okay. Now let's try for the X intersection Y. So X intersection Y. So intersection means what we are going to do? We are just going to write what are the common elements. So what are the common elements here? Common elements are both B and D. So now X intersection Y will become the set of B and D. Okay. Now moving to the next, X union Y. X union Y means we are going to write the combined elements of both x and y. But here we are going to write the repeated elements for only one time. So that becomes your A, B, C, D. So we are not having E, F and G. Okay. Now moving to the next is the x complement. So they gave the universal set, which is of set of A, B, C, D, E, F and G. Okay. And they gave the x, which is the set of A, B, C, D. Right. So now just remove the elements of the x from the universal set in order to get the x complement. So we will get the x complement will be equals to your set of, after removing A, B, C, D, you will get E, F and G. Okay. So now this is how we are going to perform the operations on sets. So all these operations are very simple, like your union, intersection, complement and difference. Okay. So now just take a note, and after this we will mostly discuss about the order pairs. Okay. So yes, now moving to the next, we are at the end of the session, and if you think we need to practice a lot on these sets, see, mostly we will find the sets is the simple topic, but the extension of the sets will help you to gain good knowledge in the functions. Why? Because in order to know about the functions, you should be very clear about the relations. Okay, relations will come from the sets. Okay, there we are having the ordered pairs, so that we will discuss in the multiplication. So now just practice a lot in the sets, because you need to know what is the cardinal number, and you should be very clear about the disjoint sets also. Okay, because after you are moving to the grade 11 topics, there we can find the cardinal number, like relation between them, n of A, n of B and intersection and union. So we will find the relation between all these operations with the help of the cardinal numbers. So you should be very clear about what is the cardinality of the sets and disjoint of the sets. So practice a lot on the complement and all. Okay, you have to be like these topics are very simple for you when we are moving to the grade 11 topics. Okay, now moving to the next. So if you need any practice, okay, noted. Yes. Now moving to the next, if you want to practice a lot, we are giving the daily practice worksheets in the Telegram channel on the topics that we are discussing in our sessions. So you can scan this QR. See, in our Telegram channels, if you are preparing for NEET also, we are giving the NCERT capsules, okay, and we are giving the daily JEE Mains and Advanced questions there, where you can participate like a poll, and you can improve a lot with those modules and all, right? And if you are having still any more doubts, or if you want us to help you better with your transition course, and if you want to suggest anything, just scan this QR, and you can just mention whatever the doubts you are having. Okay. Yes. So that's all for today's class. So we will meet in our next class. Bye everyone. Take care.